Hi, this is Asphyxium, and welcome to the How to Make a Master System Game Using Devkit SMS tutorial series number 13. In this tutorial, I'll go over source code for the ghost entities, we go over the metasprite definitions, comparing the methods used versus the player streaming methods, we discuss the general pathfinding logic for the ghosts, we also go into detail about each state that a ghost can have and the behavioral differences between each ghost. This is going to be the biggest amount of code we've gone over yet. Let's begin. Okay, so now we're going to focus on the ghost logic in our source file, the ghost source file. And we're going to do some of our constant setup in the beginning of this file like we did with the player file, source file. And the first thing we're going to bring over will be the sprite definitions for Blinky. So again, this is very much set up like player 1 when it comes to the metasprite definition. There's only 2 necessary here, but for the ghost, since we're going to do it more of a in-memory traditional sense, we have to define the sprites a bit more here, whereas we're only using one metasprite for each player, for player 1 or 2. Here we're going to have multiple metasprites defined for each way that the ghost may be facing at that point. So here you have Blinky right 00 and Blinky right 1, essentially saying that there are 2 frames of animation here. And when we go back to graphics editor, it will be these 2 frames of animation facing right. So as we said before, with player 1 and player 2, the tile IDs would be 0, 1, 2, 3, 4, 5, 6, 7, and then this one would start on 8. So 8, 9, 10, 11, 12, 13, 14, 15. But it would start here on 8. As you can see, that's how I have this set up. So as I said previously, these are the X and Y values, so the positional values of the sprite. And then the third number will be the tile ID that represents that sprite. And in this metasprite, we need 2 tall sprites to make up the graphic. So here we're saying tile ID 8. Since it's a tall sprite, it also encompasses tile ID 9. So a tall sprite, that's what would happen here. And then with the tall sprite for the second sprite of this metasprite, it's at tile ID 10 at that point. And we're going to offset the horizontal value over by 8 pixels like we went over with the player tiles. That second sprite here will be offset to the right by 8 pixels. So we're doing the same thing here. So that's how we define one frame animation in that case. We could also use Devkit SMS to do this. I mean, not Devkit SMS. SMS Tile Studio to do that heavy lifting for us as well if you want to import and then do the same thing we did with Miss Pac-Man. But there's really no need to do that since all this data is in a sequential format. We don't really need to go through all that, but just to go over it again. So this would start at tile ID 8, and that would also include 9 since it's a tall sprite, and then the next one will be tile ID 10, and that would include 11. So we have 2 tall sprites that make up our metasprites. So that's frame 1 there, and then frame 2, you can see it's offset just a little bit at the bottom here. And so we're gonna get our next one. So that since this was at 10, then this will start at 12 and this will start at 14. So we're going to look over that. So here you can see with our second frame of animation For Blinky, we have the same offsets for the sprites. Here we're starting at tile ID 12, which is right after 10. And then same thing with here, we're going to the next tile ID batch for tall sprite, which is 14. And we're going to offset again on the horizontal value for that one sprite, making the entirety of this metasprite again composed of 2 tall sprites. And then at the very end, we're going to take those 2 frames and we're going to stuff them into this array, this pointer array, so that we can reference it later, much like we did with the player. And then again, this just continues. So the next set is Blinky going down. So we're going to go again here. So, this is 8, 10, 12, 14. Then this one starts at 16, 18, 20, 22 to get these next sprites. So it'll be down, and then it'll be left, and then it'll be up as the final set of directions for a ghost. And that's all we're doing here. We start from the right, and then we go clockwise. So right, down, left, up. And you can see we do essentially the same thing. And you can see these tile IDs incrementing. So here's 16, 18, 20, and 22. And then the next set will be at 24, 26, 28, 30, and so on and so forth until we get it all put together. So that's what we're doing here with these metasprite definitions for Devkit SMS. We're going to do the same thing for Pinky. Pinky is next on the sheet, so this is what it would look like in our VRAM for the most part, is that it would start with Blinky, then Pinky, and then Inky, and then Sue at the end, and then some other graphics that we'll have to make metasprites for, or metasprite definitions for. So that's all we're going to do here. We're going to go down the line again before we left off. We left off at tile ID 38. Now we're going to go to 40, 42, 44, and we're going to keep going down the line, and we're going to find our metasprites for the rest of the ghost. Inky, again, we stopped at 70, now we're at 72, so on and so forth. The definitions are pretty much the same. The only thing that changes is the tile ID, because the graphics are different for each ghost. So we did that for Inky. Now we did Sue, and we're at 134 on the tile ID. And then we're going to keep going with it. So our next set of graphics are the frightened graphics. So we ended up at 134. Well, then our next set will be 136. We can take a look at that. So here's our frightened graphics. So we have these 2 frames in a row that will be part of that. So frightened 0, so it'll be 136, 138, and then 140, and then 142. And here we have frightened frames as 4. And the reason why we have 4 frames for this is because of the way that we're going to flash the ghost. We're going to have it that the amount of flashing when it comes to the frame count is going to be matched the same way. So we're going to give 4 frames for this, and you'll see later how that plays into us. Even if it's just repeating, as you can see, we're repeating these 2 frames of animation for 4 frames. There's a reason why I do this, and it's mainly for the simplicity of when I go to flash the ghosts. So the next one would be the flashing 0 and flashing 1. So again, we get done with the frightened ghost graphics. Now we're going into the flash graphics, which are the next set of 2 metasprites here we have. We're going to put that together. So you'll see that I have frightened here first, and then I'm flashing or doing the white portion of it. So there's 2 frames of the frightened, and then it flashes the last 2 frames. And again, that's done for a specific reason and to make it match up with this. So you'll see that later. So again, we're just defining more of our sprites. Here we're going to create the graphics for when the ghost is chomped, and after the ghost is chomped, it just becomes the set of eyes that returns back to the ghost house to regown. So that's all we're doing here. Again, that's part of our VRAM map. So we have 1, 2, 3, 4 different metasprites for each direction. So we're going to find those here. Again, we're going to leave off at 150 and then 152, 154 for the tile ID or the graphic that will represent our sprites within the metasprite itself. So, and then again, we're going to add those directions to the chomp directions. Again, for different frames there, but obviously there won't be any duration to it. It'll just be whatever direction they're facing, as there's only one frame for each direction. Okay, and next we're going to define our markers, and the first one in the batch are I believe is our down marker. So we're going to define these down markers. Most likely, I haven't looked yet, but I'll probably be skipping over, as I didn't put all the down markers all in one continuous thing. It looks like I alternated based off of the whatever ghost it is. So most likely the tile IDs will be a little different here. So as we went from 160, 168, 170 to define down marker for Blinky, but as you can see, this is 176, not 172. So that 176 is the tile ID for Pinky's down marker. So when we go look over it, Pinky down marker starts here. So there's about 4 tiles that get skipped to get to this, or yeah, down marker. So it'll be these tiles for the metasprite, these ones for the metasprite, these ones, and these here. So that's what we're doing here. That's why there's a skip. So we have 170 to 176 at that point. And then 178, because this is one entire metasprite. And the same thing here. We start 184 and then 186. And that will make our metasprite for Inky's down marker and Sue's down marker will be 192 and 194 for the tile IDs. And then we put them in this pointer array, so later we can reference them easily with our frame indexer. Up markers, these are the other markers that show at the top of the screen and pointing up. So again, we had that 170. Well, here's a 172 and 174 for that graphic that happens right after the down marker for Blinky. So that's where it's all defined. Same thing, nothing too crazy there. And then there's the frightened ghost marker. So these are the markers that are the blue markers for when the ghost is frightened off the screen. So here we have 2 markers for that. And then when the flashing portion comes in play, it will flash from this to whatever the ghost's normal marker would be. So if it would be Blinky, it would, when we're in the flashing phase, it would flash from this blue to Blinky's graphic in that scenario. So it would alternately blink depending on whatever the ghost entity is. So, and that's all we're going to do here. We're going to, that's going to be located at the 200 tile ID and 202. And that's for the frightened down marker, and then for the frightened up marker, the sprites will be at 204 and 206 in the tile ID. This is just one metasprite, so you don't really need it to be put into a pointer array of any sort, because there's no directions applied to these, and it can be generically applied to any of the ghosts. Here we have the points, so all the points that are available after a ghost has been chomped. And again, we can go back to our graphics editor and see where that plays in into our whole thing. So we have these graphics as our sprite graphics for the points. So, and they're optimized to a certain degree. So this portion here can actually be used with the 400 and 800 to complete the metasprite. This one at the end here, where the 1600 is just off by a pixel, as you can see from the grid, this goes right down the center, and but this 1600 actually goes down over just a little bit. So this is its own graphic altogether. So we can optimize if we're going to reuse them somewhere else in the sprite. So we can have one graphic that can be reused with other things to optimize this. So the end of this 200 can actually be used with the 400 and can actually be used with the 800. So that's how we're going to set these metasprites up then at that point. So let's take a look at that. As you can see, is 208. It starts with the tile D and then 210. And that'll be the 200 point metasprite. Then here we have 212 for the next one, which would be for 400. But as you can see, we reuse 210 from the 200 points, and we're just going to reuse those within the 400 and 800 tile IDs for those metasprites. So these are using a similar tile ID to make up or comprise the graphics for the metasprite. So again, that's some ways to optimize it. And then with the 1600, it has its own set. So here we have 216 and 218. Those are those two tile IDs that are consecutive from one another when we look over here. So it'll be these two or four tiles altogether, or two tall sprite two sprites to make up the metasprite. So that would entail everything that we need for the ghost entities. As you can see later on, we're going to put in our bonus graphics at the end here, and we'll go over those when we go over that source code. So, and I know we went into some detail while discussing the graphic resources, but we'll see how that looks like when we get to the bonus source code. Okay, so all our sprites, our metasprites, have been defined. This is what we're going to use for everything that has to do with the ghost entity. So we're moving on, and the first call or function we have here is set ghost. Again, as I described in the previous video, I like to have one function that loads an entity and then another one that updates it through the game engine, and this is the loading portion of it. Again, you can see that we have quite a lot of parameters here. Normally you want it to be 2 or less. Here it's quite a bit, and I'm only doing this at load. I'm not actually going to be using this function in particular when I'm going through the game engine. So this only gets loaded when the game state gets loaded, and you'll see that when we get into the stage source code and the game source code and all that stuff, how that plays with one another and what the hierarchy is when we put things together. So again, it's just whatever the ghost index is, and that's all, everything is based off these defined. So we have indexes here for each one of them. I start with the ghost first. Again, it lends better when you want to iterate through them through a loop or a for loop or something like that. So that's the reason why we do that. When the substate is cleared out, and whatever state that we hand it over and the direction that we hand it, again, these are all those defines, those constants that we went over, and the we're setting the frames and all that stuff. So this is essentially setting up one of the ghosts, whatever one you desire. And again, we'll see that when we go to run the game engine under the stage source code. The next one is update ghost sprites. So this is where we're actually going to add them into the SAT as per the Devkit SMS functions. So again, much like the player, we're going to load these sprite definitions into VRAM. Whereas with the player, since we were doing a streaming technique, the update sprites functionality there was kind of small. This one, since we're doing it not in a streamed way, we're going to have to do a bit more logic here to set up the sprites. So let's go through that. So we're going to get whatever the current state is. So we have a local variable here. As you can see, I have 3 of them here. Like I said before, you typically only want to have one and use it as an indexer, but I did a lot of testing with this, and I found that if I pop certain things into a local variable, it actually gave me a few more scan lines, or 1 or 2. It saved me some processing power. So again, play with that. Sometimes it makes more sense to just offload whatever that is, like a global property for entities. It might make more sense that you stuff it into a local variable and then use that throughout the rest of your logic. But I usually want to just stick with at the very most 1. In your best scenario, not use any local variables here within the definition. But here we're just going to check, and obviously this could have been done probably a little better. Maybe I could just use this for this check instead of creating this before this. It might have been a better idea to do this check, and then if it's true, then load the variable after this, because doing this before the check, probably not very optimized. But anyway, I digress. So we got our state, whatever our current state for the current ghost that we're feeding into this. So we're gonna get the ghost that we're being fed into. We're gonna get its state, and then we're gonna check it. If it's none, as I said before, if it equals none, then we can bounce out of it, and there's no reason to draw the ghost at that point. So that's essentially what we're doing here. Here we're going to set the entity visibility for the given ghost. So it will be if it's within the viewport, outside of the viewport in some way. We already went over that. I'll go over that ad nauseum. We did the same thing with the player. We offset the sprites by 8 so that the origin's actually in the center of the graphic. So that's why we're offsetting. Again, we could have done this offset within the metasprite definition. So that would have been perfectly fine to do there. But here I do it with this arithmetic and said the same thing that we're doing, the offset from the scroll. So wherever our vertical scroll is, and then we're going to add that offset of the scroll amount. It always applies to the ghosts, so there's no reason to condition if this is the entity creating the scrolling, because that will never happen. So we're just going to add that global scroll offset to the vertical position again, which would be typically either like a -1 or a 1, or if the players got the pack boost, it'd be 2 or -2, that sort of thing. So, and that's what would be applied to this vertical position. So then here we're going to check the entity visibility. So if it's out of view at the top, we're going to do very much like we did with the player. We're going to set it as a marker, and here we're just doing a little bit more conditionals for the marker, because the marker may display that when the ghost is in the frightened state, it's going to show that marker for a while until the energizer time reaches a certain amount. So we would put that ghost marker in there. So equals, if the state equals frightened, so if the ghost is frightened and the energizer timer is below or equal to our halfway point, so that's saying, okay, the energizer timer is at the halfway point, this is when we're going to start flashing. And then we're going to check the entity frame to see what current frame it is. If it's above the first 2 frames, because as you remember, the first 2 frames are just the frightened state, and the second 2 frames are the actual flashing state. So we're going to look above those 2 first frames. So if we're beyond those first 2 frames, which is the blue ghost, so the animation, so it has 2 frames of animation, which is in 0 and 1, and then 2 and 3 in the index has the flashing one. So those 2 frames of animation for the flashing portion. So that's what we're going to look for. So we're looking for that flashing portion, and then we're going to get the appropriate marker because of that. So, and it's going to be based off of the X value of the entity, and as you can see, we're hard coding the Y value. That means that marker is always going to be at the top of the screen until the ghost becomes visible again. And then here it's just if it's just frightened, we're just going to use that frightened up marker for that. And then if none of these conditions are true, which is everything that revolves around frightened and flashing, we're just going to give it the normal ghost marker. So again, like this is what the I'm sorry, this ghost marker, I'm sorry, it's flashing, but it won't have the white one. It will have the actual regular ghost marker that would be applied to it. So when it's frightened, we'll have the blue one. When it's in between those frames, when it's flashing back, I will use the normal one to say, okay, the ghost is about to get out of frightened mode. So again, yeah, we don't have the white ghost marker. So what I was talking about before is we don't have a version of the ghost marker like this. We did at one point. I did have one for the blue and the white ones, and it had a flashing animation, but I couldn't fit the entirety of those graphics in. So, and I like this idea better, where we're flashing between this and the ghost. That gives the idea of what ghost is coming out of the flashing. Whereas if I would have this as a flashing white, you wouldn't know what ghost that was until it was done with its flashing and frightened mode. So, and that's the reason why I took that position. So yeah, I'm sorry, I misspoke here. I will just go back to the normal ghost marker, whatever the ghost is, and then here's where we would flash it blue in between these frames here that we talked about. So that's for the top, out of the top view, and then out of the bottom view is the exact same thing, except we're doing it for the bottom, and you can see that our offset is at 176 because of the way that we have the ghost marker showing that it'll be I think at the origins at the top left, so we have to put at 176 because that also takes into account the 16 pixels high that the graphic is, and probably I don't want it to touch the very bottom of the screen, so maybe whatever the reasoning was for 176, that looked good for me to show at the very bottom. So that's a hard-coded value, and as you can see, if any of that happens, we return immediately. We don't do anything else. Here, if bouncing at offset. So this is only, the only places it's being used is one of the cutscenes when the ghosts run into each other and they bounce off each other. It's the only time that I'm actually using that, and I'll make the substate at the bouncing substate for that. And again, we're going to use a LUT for that. There was that LUT that I was talking about, the lookup table that I was talking about when we went over the global variables or the global source code at that point, and all it does is we're going to increment our LUT index as part of the entity properties. Again, like we did with our frames of animation, we're going to add one. We're going to check if that's more than the amount of frames that the bounce has. So it has 18 elements in here. We're going to check if it's equal or greater than that. If it is, then we're going to reset the bounce animation. Otherwise, we're just going to increment it at that point. And then for the bounce, what we're going to do is we're going to add whatever our Y position is. We're going to add whatever the bounce array has in it. So whatever the current index is, we're going to add that offset to the Y, and then it's going to make it look like it's bouncing based on whatever our index is within that bouncing offset lookup table. And again, you can refer back to when we talked about this in the global source code. And then if there's no bouncing, if there's no flags that needs to be done here, then we're going to get right down to whatever our current state is for the ghost. So if the ghost is frightened and they're on screen, this will handle the metasprites that are going to be handled for this. So here you can see if it's not flashing, that means that we're greater than the Energizer time half, like we went over in the player source code. That's where it gets set. It's going to be half the timer count of the Energizer timer. And again, that timer is based off a stage, so it's shorter for later stages. but we still need to know what that half timer is for that. And then here's when we're actually flashing, so it'll be that white flashing that we were talking about. Here we have some fall through. If the ghost is chomped, or the entity is entering the ghost is entering the house, that means it's going to have those eyeball graphics. So when the entity's chomped, it's going to be a set of eyes, and it's going to go around till it gets back to the ghost house. And when we're entering the ghost house, we still want to have that eye graphic showing. So that's what we're doing here. And we're going to show that graphic since it doesn't animate. It's just one frame. We're going to show the ones that we have for the entity direction, because the way that we placed these graphics or the metasprites in this is based off of what it would be for the entity direction constant. So there's defines here. So here we have right, down, left, up, 0, 1, 2, 3. That's the values behind them. And we go up to chompters up here. You can see that I put right, down, left, up. So when the ghost's direction is used, which is one of those constants up there, it'll be 0 for right, 1 for down, 2 for left, and 3 for up. So then that's what we're using there for that argument. So we're going to go to those chompters, and then we're going to give it the direction that the ghost is facing in, and then I'll get us the correct metasprite that we were looking for within this. So that's what we're doing there. If the entity state, so the ghost, so this is one chunk of code here because we have the break here. I'll break out of that. This is one chunk of code, and this is another one here. Here we're checking if the entity state of the ghost is the point state. So that's when they're chomped and they turn into a point representation. So the 100 or the 200, I think it is, 400, 800, 1600, whatever those are. And then based on that global variable that we went over in player source, this is n through when we went over the global source, this is the accumulator for that point. So if it's 200, it's going to show the point's 200 metasprite, so on and so forth. 400, if it's 800 and 600, 1600, will show the correct metasprite that we have defined at the x and y coordinates that we calculated up to this point. So this is when they turn to points. This is when the eyes, and this is when they're frightened. Here the default is just their standard graphics then. So this chunk of code here is just checking, okay, what index is this? Is this Blinky, Pinky, Inky, or Sue? Which one is it? If it's Blinky, we're now going to look at the entity or the ghost direction, which way they're facing, and then based off, okay, is it right, down, left, up, we're going to add the metasprite here as Devkit SMS gives us, and I didn't go over that, but yeah, so all these are just calls by Devkit SMS to add the sprite to the sprite attribute table, or the SAT. So we're going to add our metasprite into the SAT so it can be drawn on when we make that call to update the SAT. So here we're just defining what sprites we're going to put into the SAT, and then that final call later when we go over it, we'll actually push these to the VDP port and actually update the graphics or the SAT data within VRAM. So that's what we're doing here. We're just checking which ghost is it, and then we're going to check the direction of that ghost, and then based off of that direction we're going to feed it the correct graphic for that direction. And you can see any frame still used, so whatever the current frame is, which would be, in this case there's only 2 frames, so it would be 0 or 1, and as you can see there's only 2 elements here. Blinky up frames 2, that means there's only 2 frames of animation, so it can either be 0 or it can be 1 in this scenario. So that's all that this is, and we're going to move on to the next function. should be no surprise that the next function is to update the ghost frame. Again, this is very much like the updating frame animation stuff for player 1. As you can see, it's much smaller in player 1. That's because of the way these are being handled graphically. The players are streamed in. These are using already set graphics within VRAM. So as I said before, this will be more complicated, and this would be much less complicated. So that's what we're doing here. So if it's paused, or the entity frame duration isn't up yet, so it hasn't been counted down to I think it has less than 0, then we're going to return, because there's no reason to update the frame animation until that duration is over, much like with the players. And then here we would just go and, based off the whatever the entity state is at this point, we would. So for points and chomp, there's no frames of animation. It's just one frame of animation, or one frame of graphics. So it doesn't need to have any sort of reset on the frame. The frame's always going to be the first frame. So here we hard code the first frame. And then we have the entity duration, the 127, because it is a signed number. That's the maximum amount we can give it. Another way we could have done it is if we could also check if this state only has one frame, then we wouldn't even get into this logic. But instead, all I do is offset it by the maximum value, so it won't come back into this code until 127 frames are up, and then it would look at it again. So it's a little wasteful, but it's cleaner this way. So, and it's not really all that much different from updating frames later in the game anyway. So here again, since these are only one frame, and you can see I do a fall through with the point state, and then fall through into the chomp state, and this is one chunk of code with the break here. And again, it's just gonna always keep it that any frame is the first frame, so everything starts at 0. And then with the frightened state, since it has more frames than the other ones, I'm just going to do the check here. So we're going to try and set up the next frame. The frame plus 1, much like we did in some prior code here that we're checking for the max for. If the entity frame plus 1 is greater than the maximum amount of frames of animation that the frightened state has, then we're just going to reset it back to 0. Otherwise, we're going to increment it to the next frame. And then here we also set the duration for the next frame that we're going to use to count down up here before we look for our next frame. So here it's times 6. That's for the NTC version. And then for anything else, everything else uses only 2 frames of animation. So again, we're just going to check, okay, this plus 1 is going to be greater than or equal to the maximum frame rate. If it is, we're going to reset. Otherwise, we are going to increment. Okay, I think that takes care of that. It's pretty self-explanatory, kind of short. Reset ghost frame, this is just a handy feature or a handy function I use to reset everything back when it comes to the frame, current frame, and then the entity frame duration. It uses in the engine code, and maybe some other places. I think I use it when we want to reverse directions or change anything that has to be like a reset of the graphic. So it's pretty self-explanatory. We just set to the properties for the given ghost. Set ghost reverse direction. This is when it happens when either the ghost enters a frightened state, or the ghost that that timer that changes the ghost from idle to chase, and then chase to idle. Whenever that occurs, the ghosts, all of them will change direction if they're out on the maze. So Here we're going to reset the ghost frame, and then we're going to reset the previous tile so that on the next loop we will make since it's there a change between the previous tile and the current tile, that means then it will update the logic of what its next target is. So, and that's why we do it here, to force that update. Now that the previous tile, no matter what it is, we're going to make it 0 because previous tile can never be 0 because it's in the top left portion of the map, and there's no way that the player can get to that portion. So that's what we're going to do there. And then we're going to get whatever the reverse direction is for that. So if it's down, we're going to set the entity dir to up, or direction, left, right, pretty self-explanatory. We're just going to give it whatever the reverse direction is, and default would be right. So then the opposite direction of right is left. Set all ghost states. So we're going to hand it a state, whatever that is. So one of our defines from our states that we've put together here somewhere. Here we go, any states. So one of these states will be handed over to this function, and here's going to set the ghost processing flag. And I discussed this in the globals source, where we're telling the engine that we're processing a ghost at this point, and that will offset or stagger step the ghost logic so that it doesn't overwhelm the game in one shot. Because what happens is, if we would do, since we're doing all the these for loop here for all the ghosts, that's actually quite intensive to do this while we're running the game engine. If you set the ghost processing to 1, it will skip any other processing that the ghosts are doing currently, and then we can call this safely. Because if a ghost is currently trying to find a target, and that logic to find the target can be, depending on what ghost it is, it can be pretty hefty. When we set the ghost processing to 1, that's telling any other ghosts that needed to be processed within this frame to not do any processing, because we're doing this specific for loop for all these ghosts, and their state's going to be changed most likely in some way. So this is actually a very intensive call. You don't want to call it while other logic is being done by other ghosts. You want to tell them to stop processing so this for loop can do its thing. So that's what we're doing here. We're stop processing for this frame, and then we're going to loop for all 4 ghosts. You can also unroll this loop if you wanted to, but it would be humongous, and I didn't do it for this. This isn't like so intensive that it's necessary for me to unroll it, but because it's not something that gets called every frame. This only gets called when certain conditions happen. So like, you know, when the player eats an Energizer, and then it has to change all the ghosts over to frightened mode. So there's only certain cases this happens. This doesn't happen every frame. So, but we're going to go through all 4 ghosts again. We're going to use this for loop. We're going to start at 0. And as you recall, I set it up that the ghosts for these entities were the index. So I set the index again from 0, 1, 2, 3 for the ghosts specifically in the beginning, and that's more of a strategic move, so I don't have to define another number and then go through iterating. So I can do it in consecutive order, using it from 0, and then I'll iterate through every ghost. So here we're gonna check the state that was given. If the ghost is already frightened, or I should say, if the state given is that we want to frighten the ghost, but if the ghost is already frightened already, there's no need to do any sort of crazy logic. So we're just going to just reverse the direction. So every time they're set to this frightened state, they will change direction if they're already frightened and the one state that we're bringing in is to frighten them, then there's really nothing else that they need to change when it comes to the rest of their properties. All we do is set the reverse direction, and then continue means that we won't be doing the rest of this logic down here. Continue means, all right, we set what we want to set, let's just continue to the next iteration. So here what would happen is, instead of, when you call continue, instead of doing any more logic here like this bottom logic, it would actually kick out of the loop and then do the increment, and that's what continue means here in a for loop. You could also break out of a for loop if you wanted to by calling break. That will break out of a for loop earlier. So if there's a condition that you're looking for and you're iterating, it might have the possibility of breaking out of the loop earlier in certain scenarios if you're looking for certain conditional. So that's another thing you can do within a for loop. So then we check, all right, is the any state none? If it's not, and it's greater than the frightened state. So again, this is another thing I strategically put together. If it's in a state that can't be overridden, so any state none is not, when that's being placed in here, that has priority over everything. So as long as it's not that, as you can see, if we go to this definition, that frightened here at 11. So if it's the current state of the ghost is higher than frightened, these states cannot be overridden. So when they're in points, and say there's another state that comes in, because when we set the state, so let's say the ghost is in points, so it's making its way back to the house. If the player eats another power pellet, it's going to try to change the state to frightened. Well, if it's already in points, there's no reason to put it in the frightened state, because we can't override the point state based on that frightened state. So, and again, we're not going to override when they're in the house. We're not going to override when they've been chomped. I'm sorry, the points. This is the state that shows the actual points. So we're not going to override when they're displaying points. We're not going to override when they're in the house. We're not going to override when they're in that eyes state when they're going back to the house. And we're not going to override when they're entering the house or leaving the house. So these are states that are not overridable. And I put them there for that reason, for this condition. I don't want to like piecemeal and check every condition. Okay, all right, are they points? All right, are they house? Are they chomp? No, we just want something that's one condition check, and that condition check is to make sure that if it's over the frightened state, those are states that can't be overridden. So we're just going to continue. We're not going to do any more logic here. We're going to break out of this loop and go and iterate to the next one. So that's all this is saying. Continue to the next ghost, because this one can't be changed at this point. If none of those conditions are true, now we're just going to check, all right, as long as it's not the state of none, we're going to set our reverse direction as we did here, and then we're going to update these properties. So the timer, any timer is going to be reset to 0. Any target tile will be reset to 0, so that means we have to look for a new target. And then any state will be the state that we wanted it to be in, so whatever state that came through. And that's all this logic does. So this is on the set ghost mode. So whatever that ghost mode that we were talking about before, whatever that it's going to be. So it could be scatter or chase or whatever, idle and chase, whatever way you want to look at it. We're going to set it for whatever the current player is. So I should say we're going to set it based on the current player. So whatever the current player is, if it's player 1, then we're going to set the player 1 ghost mode based on the given ghost mode that's here. And then we're going to actually say the global ghost mode for the current player is going to be set at the end. And then we're going to change the state based on whatever that current ghost mode would be. So it would either be in that scatter idle state, or it's going to be the chase state. And that's where we're going to set this. I'm going to call this that we just, the code we just wrote. Okay. Next one is ghost check collision. So this is checking collisions with the ghost. And the first thing that we're going to check is, all right, is the entity state that the ghost in, is it something that we're going to have to check a collision for? And again, this is strategic, as I went over. As long as it's greater than the frightened state, it doesn't need to be collision checked at that point, because if you remember from defines, if it's points, there's no reason for a collision. If the ghost is going or is in the house, no collision check really needs to be done with the players. And then if they're chomped and their eyeballs, there's no collision that needs to happen there, and no collision needs to happen here and here, and so on and so forth. So that's what we're checking here, is that if it's greater than this number, which is 11 here, then there's no reason to do any sort of collision check. So here now we're going to check with, we're going to use our common, or our entity function check entity collision that we already defined. So we're going to find out if we actually collided with a player, and then we'll get back that player index and we'll figure out what that target is. If the target is 0, then we didn't collide with anything. Let's bounce out of here. So that's what we're doing here. Now, if we get to this part of the code, that means we actually did collide with the player. So for that little bit, whatever happens there, whatever happens with the collision, we're going to put that special mode pause to. So we pause everything and the second player, if there is one. And we're going to check, all right, is the ghost frightened at this point? If the ghost has been frightened at this point, that means the player has the ability to eat the ghost. So if they're in the frightened mode, we're going to we're going to set some properties here. So we're going to set the state of the ghost to points. So that point value shows 200, 400, 800, 1600. So we're going to set that state to, and then we're going to have the target. We're going to temporarily set the target to the player that the ghost ran into. So we're going to set that target, and then for the small moment when the player chomps a ghost, when the score shows up, the player disappears during that portion. So we're going to take our target and we're going to set the state to none. So that means we're not going to show it. We're not going to show the player. And then we're going to set our ending timer to 0 here, because we'll need that later when we're going to show the player again. Then all we're going to do is we're going to increment that ghost point accumulator like we typically would. If it's 0, we're going to set it at 200. If it's not 0, then what we're going to do is, as you remember, if you shift to the left, we multiply. And if we look at bit 1, it has a maximum value of 2. So here we're saying, all right, now we're going to times it by 2. So if it was 200, it would be 400. If it was 400, it would be 800. If it was 800, and then it becomes 1600. So that's what we're doing here. Again, we're using shorthand to do all that. And then we have a switch that says, okay, now that we know what that accumulator point is, we're going to add the score to whoever was the target or who was credited for that. So, and in the beginning, we're going to play this track then. So and that's when the first bite. So when the first ghost gets chomped, it will make the regular chomp sound here, but also would make that ambient sound from after you chomp the first ghost, which is hard for me to explain. But there's an ambient sound that gets changed here that we would use at this point. When the player hits the energizer, it hits a certain sound, and then after we chomp the first ghost, we change that track to after the ghost chomp track, and we play a sound effect of eating the ghost. And then after all that's been done, so the ghost gets chomped here, we're going to return, because this is the rest of the code down here as if the ghost was not frightened. So here's when we actually chomp the player instead. So we stop all the music, we set the state to the target, whatever it is, player 1, player 2, and we set it to chomped. Again, we reset that entity timer again. And then we set the auto scroll direction if the player's off screen. So we're going to check the visibility of the target that was chomped. If it was off screen, like it was player 2, we would set that auto scroll direction, whether it's go up or down. And then what would happen on the state of the target, it would scroll all the way down to the bottom to where the where the player is before it shows the rest of the states, or it'll go up to the top of the players at the top of the map. So here we're just setting whatever that direction would be for the auto scroll. And then whatever the current player is, if equals player 1, we're going to reduce 1 life off of it. If it's player 2, then we reduce player 2's life. And in team mode, the players share the lives, so it would always be player 1. So next, set available ghost available direction. So this has to do with our ghosters array that we talked about when we did the global source code, and there's 5 elements in there. Roll over, it should show 5. Yeah, ghosters 5. So there's 5 elements in there, and I went over some of that logic when we talked about the globals. I'm not going to go too much more into it, but here we're basically checking some stuff. So we're going to hand it the tile that we are interested in looking at, which typically would be the tile that the ghost is currently sitting on. So it would be that tile, and then the direction that we're trying to, or the direction that the ghost is currently facing. So we do a first check here. First we check, well, we're going to do all 4 directions here. So for right, which is 0, if you recall, if I hover over, it's 0, and then down is 1, left is 2, and 3. So we're going to set the direction for the right side first. So we're going to check, all right, first of all, is the direction that we're currently going, is it left? Right away, if this is the opposite direction, then it will be that the ghost will not be available to move, because remember, they can't move backwards. So here we're checking if they can, if it's the opposite direction of the current direction they're moving in, then we can't go backwards. That was part of the thing. So we automatically say this is 0. We can't go in this direction. However, if it's not that, then we're going to actually do the logic to see what that tile is. So as you remember, I said tile is the one that the ghost is currently on. If we want to check to the right, we have to add 1 tile to it. So it's whatever the tile index is plus 1. So we're going to check that tile to the right of the ghost. Remember, as long as it's not the opposite direction. And we're going to check if it's greater than our solid, which is 340. And then from there, we're going to say either 0 or 1. So 0 that it can't move, and 1 that it can. So 1 is the only value that would say that we were able to move in this direction. So again, that's what we're doing. So that's what the logic is, and we're going to do it for every single direction till we get all those. So there'll be either 0 or there'll be 1. And ghosters on the very last one, here we have 4. So directional, this is where we're using that special case constant. On the very last element of ghosters, we're going to add up all the other elements. So whatever these values are, either 0 or 1, we're going to add them all up here, and we're going to set it to our direction, or the 5th element in this ghosters array, which we will use later to determine if we need to actually do any logic, or if we can just move the ghost in the current direction it's in without doing any other additional logic, which would be to check what the target would be. Set ghost random available direction. So set rows. It's basically handing in the ghost, the current ghost, and then so we're going to figure out what our available directions are based off of the, like I said, the current direction of the ghost and the current tile index that the ghost is on. So we're going to set those all up. Then we're going to get a random number. So get RNG is that one that we said. You have that power of 2 going on there. So 6 is the power of 2 that we're handing it. So we look back on that. Power of 2. So 664 would be the actual value. So hand it bit 6 here. So when we look at 255, we divide it by 64. That gives us a value from 0 to 3. So 4 values. And that makes sense in this because we're only looking for a random number between 0 and 3 because we're going to use it within our ghosters here. So we're going to get that random number, whatever it may be, from 0 to 3. And then what we're going to do is we're going to use this other loop, which is called the while loop. And what it's going to do is, as long as this is true, this while loop will keep going and going. And once it becomes false, we're going to break out. So all we're going to do is going to check that random number and see if we can move into the directions. And then if we can't, it's going to be offset just a little bit on bit 3. We're going to mask. And eventually we'll get a random number that is available within the ghosters. And then once that happens, we're going to pop out and we're going to set the entity direction to that random direction that we got from this function or this computation. And then we move on. So that's what happens there. And that will happen when typically when the ghost is in the frightened state and is trying to move away from the player. It's just a random number basically. So when they get to the intersection, if they whatever variable choices they have based off of this, it's going to choose a random tile to move into at this point, or a random direction really. Okay. This one, I used to have this as a loop, but I unrolled it, so it makes it kind of big. I unrolled it because it is a decently intensive function. So here we're going to get all the available ghost directions. These two won't be playing at the same time. Usually when the ghost is in frightened mode, it will only run this one, but if it's not in frightened mode, it will set its target up here through the set ghost direction. So we're going to give it the index of the ghost and then the target, which is the tile index of the target it's trying to go to. And if you recall, it can be either the player, or it can be a tile around the player, or it can be any tile on the actual stage. So, and some of those tiles are outside the stage, as we talked about when it came to when the ghosts are in that scatter mode or the idle mode. It'll just go into a corner somewhere, a random corner of the stage, and kind of loop around a while before it changes over to the chase mode. So whatever our target index or our tile index is, this is what the target's going to be. So we're going to get our available directions again, like we did before, so we know what's available to us. Here we're going to check, okay, if when all these are added up, is it equal to 1? And then we're going to check, all right, is the current direction that the ghost is in, is that the direction that equals 1? And if it is, then we're just going to return, because then we don't need to set a new target here. We're just going to do our basic movement for the ghost. So here we're going to check, all right, if all those added up equals 1, that means only one direction out of all 4 is available. And then here we're checking, all right, the current direction that the ghost is moving in, is it that one direction that's available? If it is, then we're already moving in, or we're already facing the direction that the only direction we can really face in at this point. So, and then we're going to return. There's no reason to do any more logic after that. However, if that is not the case, then we're going to try and figure out depending on whatever our target is. We're gonna we're gonna give the target. We're gonna try and find the shortest distance. That math that I was talking about before that we have in the entity source code. We're going to get that distance. So first of all, we're going to, again, we would normally have a for loop for this, but I'm going to go and we're going to start with the right facing first. We're going to check, okay, is that available? So is it greater than 0? If we're meaning that it's not a solid or it's not the reverse direction or anything like that, this is a direction that is available. So we're going to do that, and we're going to get the distance. We're going to feed it the index, or the tile index, which really I could have just put this in there. +1. I used the global, whatever. So we're going to add 1 to that tile, yeah, because it's going to be the entity tile and then the tile to the right of it. So whatever the ghost tile is sitting on, we're going to add 1, so it's going to check to the right. As you remember, if we add 1, it goes to the right, and then we're going to take the tile that the entity is on currently, or to the right, and we're going to compare it to the tile that we want the ghost to go to. So we're just going to get that distance, and as you can see, distance starts at 0. So then after we get that distance, we're going to check if that's less than or equal to the minimum distance that we currently have at this point. If in this case, minimum distance will be the maximum value a short can be. Remember that 65,535, we're giving it that maximum amount. So if it's less than the minimum distance, which it should be here, if this is the first one checked, remember this condition might be that it wouldn't be something that we could check. That minimum distance, as long as it's equal or less than that, then we're going to change our current minimum distance to the distance that we calculated here. And then the entity direction, for the ghost, we're going to set that to right, because this seems like a tile that we can move into. But this might change as we go down the line here. So then we check that, and we have our minimum distance at that point, but the ghost might be in a place that it can also move down. So we'll get the distance to that, and then what will happen here is if this is less than or equal to the minimum distance, we're going to change that minimum distance. So for instance, like we see that we can move to the right, but when we check down, the minimum distance to the target tile is actually shorter here. So now we're going to change our minimum distance to the lowest value between these, and we're going to continue that check to the very bottom. So we'll check all these, see if it's available, and then we're going to get, out of all 4 of them, we're going to try and get the smallest distance to the target. And that's the whole idea of this, is that we're trying to see what tiles are available, and then we're going to set the minimum distance based on what is the smallest distance to the target tile. And then at the end of this check, we should have the entity or the ghost going in the direction it needs to go to get to the target the quickest. So that's what this does. And again, like I had a for loop, but I unrolled it for all 4 directions, and that's what happens here. So at the end of this, what we're looking for is the shortest distance to the target, and then based off of that shortest distance, we're going to move or make the ghost face into the next direction that they're going to move into. Okay. Ghost move towards target. So again, we handed the target that we're looking to move the ghost towards, the ghost that will actually be moving. And then we're going to set that target tile, which is from here. We're going to check collision with player. We're going to check for that wrap. This is much like the movement code for player, the player movement code. And then we're going to, the target, if I set the target to the max value, that is indicating to this code that we want to get a random direction. This is because I don't want to put another parameter in here that would be a flag that would say, okay, and this time we're actually looking for a random, we're looking to move randomly, and I didn't want to make another function here. I just said, okay, if the target is the max value, then I know I'm going to look for a random direction. Otherwise, I'm going to get a direction towards the given target. Here we set the previous entity tile to the current entity tile, and the whole thing about that is this won't even trigger until these two are different. There's no point in keep on checking the target when the ghost has to move through the entirety of the tile before it can make another decision. So it won't call this when the previous tile and the current tile are the same. It'll only check is when we move into a brand new tile, and then we will call this. And after we're done with our processing, then we make them the same. So that way it doesn't get called again until it moves through the entirety of that tile and it moves into a new tile. So anytime there's a new tile that the ghost moves into, this is the only time that we're actually going to make this call. Here, after we set our stuff, we're going to snap the tile, or snap the ghost to the middle of the tile. Again, we went over that within the entity source code. So this will, if it's going horizontally, it's going to snap vertically into the center of the tile. If the ghost is going vertically, it's going to snap horizontally to the center of the tile. And this is because of the fractional portion of the speed. It may overshoot the center of the tile just a little bit, so it will be a pixel off, or it could be pixel under, depending on which way which way the ghost direction is. So to avoid it and have it make sure that it's always dead center in the tile, this will adjust it a little bit. And the original arcade one, it would do this too, but it wouldn't do it immediately. I think it did it, I don't know, you can see that sometimes the ghost is just, it's really up against the wall, and then it eventually corrects itself. This is essentially the same thing that the original game did, but it's more immediate, whereas the arcade classic, it would eventually get it to the center of the tile on just regular free movement. And the version I have, or the arcade version I have, Miss Pac-Man, which eats an Energizer, she'll actually offset by 1 pixel, depending on the facing, which is it would make the player offset from the center just by 1 pixel. I've noticed it does some interesting stuff there, but this is again to snap in the middle like I described before, and this is where we're actually gonna move the ghost. We're using that move entity from the entity's source code again, where we're just gonna apply whatever ghost it is, and then the direction of the ghost, so then we're going to move in that direction. So that's all that's happening here. My mouse is being dumb. So this is, now we're going to start doing all the ghost states that the ghost can do. Again, we defined all those states over here, so we'll do whatever states are valid for a ghost to do. And the first one is the house state, when the ghost is in the house, and either they're going to leave the house from that state, or they're going to bounce around in there for a bit before they leave, or that's basically what this is handling. So here we're just checking if there's a certain point in the map. So we're going to check, all right, is the ghost vertical position, is it less than or equal the maximum threshold that we have for within the house? So that basically says, okay, as long as we're not beyond the boundaries of the house at the bottom, let's go down. So as long as we haven't met the threshold of the coordinate, so whatever coordinate that may be, say 136 I have set there. So if we look through here and we look over here, it looks like this says 144, but you have to remember that the sprite is actually 216 pixels high. So you see here it says 136. If we reach 136 here, as long as we're less than that 136, we can move down. So that would mean, like, if the ghost is here and it's moving down, it can move down until it hits 136. And then with this other logic here is if greater than or equal to 144, then we can move up. So, and that's what it's just basically bouncing the ghost up and down here. So that's all we're looking for, is these thresholds. So it said if it's greater than or equal to 144, we move up. If it's less than or equal to 136, then we move down. Or less, that we set the direction at least, and then we let the move entity do the moving for us. So we're just setting the direction here. And then there's going to be a timer release, and we only have this timer release for Inky and Sue. When it comes to Blinky and Pinky, they move out of the house immediately. At least that's the logic I have now. That doesn't mean that's the exact logic of the game. I think there's probably more to it to that. Here I have it on a timer. I think it actually it's a mixture, but it all, in the original game, it had to do with how many pellets the player consumed. So if the player consumed X amount of pellets, then that's when the ghost would move out, which would be Sue was definitely one of those, and Inky is one of those. But here I just have it on a timer. Here I'm just checking the ghost mode timer. That gets incremented constantly. I'm going to check if it's over the threshold, and then I'll set the entity state to leaving the ghost house. And then for Sue, it's an even bigger number at 420. And this only happens for certain stages. So here, stage 0, this is the only time we're going to actually wait. But after, or stage 0 is stage 1 in actuality. This is the only time we're going to wait, else they're just going to come right out. And same thing here. We're going to check if the stage here, if it's stage 2, that if it's greater than that, then we're going to leave immediately. Here, stage 1, we have to wait for that timer. This is the one it's greater in. And then, so for Sue, it would be the first and second stage that they would have to wait for the timer. The second stage would be less of a timer, but the first stage would have this timer here. But here we're checking if we're already greater than the second stage, then we're not going to even bother. We're just going to leave immediately. So this first state was when they're in a house and they're bouncing forth, back and forth, or they may be leaving. This is when they're within the house, and then here's the processing when they're leaving, or when they're actually leaving the house. So depending on, we want to make sure that the ghost is lined up with the center of the exit. So the portion here, we want them to be here dead center as they're coming through the exit. And some of the ghosts, they're off to the side a little bit, so they would have to move towards the center point depending on the ghost. Sue would be over here, and I think this is where Inky is. So we'd both be moving to the center, and then once they meet the center, then they go up. And that's sort of what we're doing here. So we're going to check if the horizontal position of when they're in this mode, are they dead center, which is 128 here. If they are greater than the 128, that means they have to move to the left. So 128, whatever to 128, it's 120. Yeah, so right here is 128. This would be here. So if we're greater than that, or the ghost is greater than that, then we have to move it to the left so we can get it towards here. If they're less than that, then we have to move to the right to get to the center. So that's what we're doing here. So if it's greater than 128, we're going to move it to the left. If it's less than the center, then we're going to move it. That goes to the right. If neither one of those are correct, that means we're dead center. That means we're equal to 128. We're going to move the ghost up. So we're going to set the direction to up. And actually, I could have just put the move entity out here. I'm going to save some time, right? Yeah, I could just put it enter. Yeah, I don't know why I did it that way. Whatever. So that seems wasteful. But anyway, so depending on whatever direction is, we're gonna set a direction. We're gonna move in that direction. So I could have used the entity dir here and used this as the argument, but here I'm calling it each thing, which whatever. It is what it is. So now we're at the center, and then we're gonna move that player up. So. And you'll see in the game, you'll see that in play. So when the ghost starts going up, now we're going to check our vertical position. Okay, is it less than or equal to 116? That means, are we out of the house yet? And remember, for us to go up, we're going to be subtracting value. So here we're going to go up until we get to, it says 116, so right below this. So we have it at y here is 112, but it would be halfway, so 4 pixels. That would makes it 116. So that's the reason why that number is there. So remember, we have to be dead center here, and this is the 112 is this point here, but we want to be 4 pixels down. So once they hit the midway point here and be right in dead center of a tile, basically, if it's less than or equal to 16, that means we haven't met our threshold yet. So, we have met our threshold. I'm sorry. So once we have met our threshold, that means we're outside of the house at this point. We want to snap that Y position just to make sure that, because again, remember, these ghosts are fractional, so it may be that it's not. Even though we're less than or equal to that 116, we want to make sure that once we get out of the house, we snap right to that 116. So that's what we're going to do. And then we're going to change the entity state from whatever this is to the current ghost mode, which would be either, in this case, scatter idle or chase mode. So that's what would happen at this point. Then we change that ghost state so then they can do some other behavior based on that state that it was changed to. So then we have the another state, which is when the ghost is entering the ghost house. Again, we're going to give it the index of the ghost that's going to be doing that. So what will happen? This will trigger when the ghost is in the chomp state. It's just those eyeballs. And when it reaches to a certain tile on the map, which is, I think it's this one here. Once it reaches that tile, it'll go from the house state, which is the it getting back or returning to the house, to the entering state when it comes down in here. I don't know if I went over that or not. Or whatever the case may be. Okay, the state would be that it's in its chomp state. So when it's in the chomp state, it's looking for this tile, and then once it hits this, then it'll change the state to entering. So then we're going to enter in here, and depending on the ghost, if it's inky, it's going to go to the left, regound, and come back out. And if it's Seal, gown to the right and move out. And all the other ones, so Pinky and Blinky, they just come in here at the bottom here, regown, and move out. So we're going to mimic that behavior. So we're going to check the vertical position, and if it doesn't meet our threshold, which is 140 pixels down, then we're going to or the NX if you haven't reached so if you haven't reached that 140 pixel, then we're going to move the ghost at the top of the house. So this is saying that we're not in the house yet, we're above the house. We're going to move the ghost to the center, and with this we're actually going to command the subspeed and speed of that ghost. We're going to make it only 1 pixel because we don't want it to overshoot. I've run into bugs where it overshoots the tile just by whatever, because again it's fractional. It doesn't happen all the time, but it happens occasionally. To mitigate that, I make sure that the ghost only for this single moment where it runs or only enters or gets to the center of the entrance by moving it 1 pixel, and I force that in here. And then again, this is much like the other code. If it's greater than 128, we're going to move to the left because we're going to be to the right of the entrance. And if we're less than 128, then we're going to move to the right, so till we get to the center. And then here's when we're dead center on top of the entrance. Now we're going to move down. So we're going to keep moving down until we get to 140 pixels down. We're going to snap that position like when we come out at the top, we snapped it. Here we're going to snap it when we get down to 140. And then if this is blinky or pinky, we're done with everything. We don't need to do anything else. So we just change the state to leaving. So once they get to the bottom, they turn the state of leaving, so they regown, and then they do the leaving state processing at that point because we changed it over to that state. However, when it comes to Inky and Sue, once we're fully in the ghost house, we're going to move them over to their side. So if it's Inky, we're going to check, all right, are they greater than 112? If they are, which is 112 would be the, wherever it would be over here, so 112 here, X. If they haven't reached here yet, we're going to keep moving them to the left till they do. And then once they do, then we change their state to leaving, and then I'll run the leaving state at that point. And then for Sue, it's opposite, so we're going to check if it hits at 144. So I think 144 is probably around here. Let's see. Yeah. So when we hit 144, position X 144, so this. So when the ghost hits this center, then it will also change the state to leaving. So that's all this does. So make sure that these two ghosts go to their respective ends of the house before telling or running the state to leave the house. So that's all this does. When the ghost has been chomped and they turn into points, that's what this process of the point state is done. So again, we're going to give it the ghost index, the current ghost. We're going to increment the ghost timer. We're going to wait 6 frames, and once we hit 60 frames. Once we hit 60 frames, then we're going to change the state to chomped, because remember, when we're in points mode, it'll actually show the points, and we want to display those points for a second before we change the graphic to the eyeballs graphic. So that's what this is doing. We're going to wait 60 frames to show the points, and then when that is up, we're going to change it to the chomp state, which means those eyeballs. And we're going to unpause because at this point, when you chomp a ghost, everything stops for this 60 frames or whatever it will be in PAL. And then once that's up, we're going to unpause everything so that we can resume the game. And then we're going to remember when we said that target, when the player chomps a ghost, we're going to take that target and we're going to change the end state from none to not show it to moving. Now we're going to show the player, and the player can start moving again. Here we're going to do the chase behaviors that was written in the Pac-Man dossier. It doesn't change for Ms. Pac-Man. The behaviors are the same from what I understand. The only things I've changed is some of the random numbers when it comes to frightened state and when it comes to the bonus, because the bonus behaves differently than Pac-Man. But so, and when it comes to Blinky and its chasing behavior, it's going to move towards the target, and the entity tile that it's going to move towards is the player. Usually the target is either player 1 or player 2 in team mode, or whatever it may be. Whatever the target may be, that's what's going to follow. It's going to chase directly towards the player no matter where they are on the screen. So here we're just giving it the ghost that's going to, which is Blinky, the index, and then here we're going to give the target. So it might be player 1 or player 2 in that case. And that's Blinky's behavior, and it's the most simple one out of them all. Pinky's chase behavior is a little different. It'll be the same as this. It will be the target, whatever the target is, but it's going to target 4 tiles ahead of the player on whatever direction they're facing. So if they're facing down, it's going to look down 4 tiles, and if you remember, a tile away from the current tile is going to be 32. So since it's 4, you take 4 times 32, and that's 128. So it'll give you 4 tiles down when they're facing down. When the player or the target, whatever the target is facing left, then it'll be, remember, left goes negatively, so you go 4 tiles negatively, and then up will add, or subtract 128. So if they're facing up, then they're going to subtract till we get to 4 tiles in front of. So it's whatever the player or target, player 2, whatever it may be, whatever the any tiles, current tile for the player, we're going to look 4 tiles in front of it. So that's Pinky's chase behavior, which is not that bad. The one that's really bad here, the one that is going to take most of the, it's more complex than anything else in here, is Inky's behavior. So Inky's behavior has to do with the position that the target is, so the player, whatever the player is, whatever the player tile, whatever tile index it is on, and it takes into consideration Blinky's position. And the whole idea is to be able to flank the player. So it has to know where Blinky is, and it has to know where the player is. And we're going to get those coordinates. So here we're going to find out what those tile coordinates are. So again, it's going to be based off of the actual pixel value. So whatever the pixel value is, and we're going to divide that by bit 3, which means we're dividing it by 8. So we're going to get a snapped tile position for the X, and we're going to snap tile position for the Y for the player. And then we're going to do the same thing for Blinky. So we're going to get those tiled versions of their coordinates. So this also, part of this is that we're not just getting the player's current coordinates or index, we're also looking 2 tiles in front of the actual player on top of it all. So whatever that target is, whatever player 1, player 2, we're actually going to increase our, whatever direction that they're facing, we're going to increase. So if they're facing down, we're going to increase our tile value on the vertical coordinate by 2. Their left, we're going to use a horizontal coordinate. We're going to remember it goes left, a negative goes left, positive goes right, that sort of thing. So we're going to adjust those just a little bit because that's part of the algorithm. Then very much so, like we did with the get position, we're going to figure out what our bigger number is before we subtract and figure out what the differences are. So we're going to subtract the differences from our target and the difference between Blinky. So we're going to take those two. We're going to find the differences, however many tiles away horizontally the Blinky and the target are, and then also the difference of how many tiles away that the where Blinky and the player are vertically. And then what we're going to do is we're going to do we're going to invert those values. So if the horizontal position of the player is greater than the horizontal position of Blinky, we're just going to offset where the end tile would be for this by the number of tiles for. We're gonna move it to the right. So basically, what it's saying is, Blinky is to the left of the player. We're gonna take that x coordinate and we're gonna invert it to the right. If the player's on the left side of Blinky, well, then we're gonna take that x1. We're gonna invert it by the difference of the tiles to the left now. The idea is that we're going to have an invert of whatever the x horizontal position will be. It will be an invert of it so that the target, it's hard to explain. It's better if I go to dossier. We're basically mimicking one of the behaviors that it is for it. So it'll probably be better if you look at this than me trying to explain it. If I can find it. So, okay, so this is where it talks about the behaviors. And Inky, you can see here. So what we're trying to do is mimic this. Inky's going to be 2 tiles away from, and this is a bug actually in the game. One of the bugs in Pac-Man is if they face up, is actually overflow and accidentally goes to the left and one facing up. But in ours, we don't have that bug. So it's going to be 2 tiles away from the player. So it'll be this tile and then the tile that Blinky's on. And then what will happen is from here to here, this is over here is where Blinky would be. So whatever it is in this offset, so say 4 tiles here horizontally from the player, it will be 4 tiles horizontally in the inverted way for Blinky. I mean Inky, sorry, Inky. So Inky, this is where the X would be, or it would be 4 tiles in the opposite direction, and then it would be however many tiles vertically from the player and this in this direction. So it would be 4 tiles horizontally, and then however many tiles it would be vertically to create this diagonal. And then that's where the whole logic comes into play, is that Inky can come in and flank the player based off of these 2 coordinates between the player and the ghost. So we're just mimicking that with this logic. So here again, depending on what side the ghost is versus the player, we're either going to add or subtract that offset that we calculate here, or the amount of tiles between those 2 entities. And we're going to do the same thing for the vertical position. So we're going to check whatever the bigger one is, and then we're going to offset by that amount. And you can see I did longhand here. I think I probably ran into an issue where that I was describing before, where it didn't really with the ternary, it didn't quite like that. So, but whatever, that's what it's doing here. And then at the end, what we're going to do is then we're going to have it move towards the target, and we're going to say that it's for Inky, and then this will be how we determine the target tile. Remember, you have to give it a unsigned short, so we're going to convert that. So how we convert that, we take our y1 that we've already manipulated, and we're going to times it by 32. Remember, there's 32 tiles across widthwise in the map, so we're going to times it, and then we're going to add our x1, and that will give us the tile index that we will move towards. And lastly, Sue's behavior isn't too bad. It's essentially the same as Blinky. It's going to move towards the target or the player. So, and all it does is, for Sue's kind of bashful, I guess. That's kind of play here. So it will move towards the player until it gets to a certain radius. So here you can see Sue, and if the target whatever the target tile is, and here we're going to say is the player. If it gets too close to the target, then it runs away to its corner over here, but it keeps constantly checking. So if it's close to the player, within 64 I think pixels it is altogether, or at least that's how I do it. Once it gets in the range and it gets to a corner that it needs to change direction, and it's within this range, it will choose this as the target. If it's outside of this range, then it will choose the player as the target, or whatever its target tile is. So that's all it does here. So it gets close to the player, then it, I don't know, gets cold feet or whatever and decides to run back to its tile that it has down there. And then once it's outside, it's like, I guess it, I don't know, it gets a little bit more courage and goes back against, try to get the player again. So that's the behavior we're mimicking here. So as long as the distance is greater than or equal to 64, that means we haven't gotten in that circle range. We're going to move the target towards the player, so whatever it is. But if it's within that range, then we're going to target to that scatter tile. So here I have those targets, and that's the one that we're going to use is for Sue. So, and that's pretty easy. Get ghost target index. I only use this for when we're in team play mode. Otherwise, it will always be the current player. So it could be player 1 or player 2. And again, we use that get RNG, and I'm handing it bit 7. Bit 7 I think is 128, I believe. So it can only be 0 or 1. So only 2 choices. And that's how we determine what the target is for a certain ghost when they are retargeting something. So it's a half and half. It's 50-50 who gets targeted in team mode. Okay. Oh yeah, and the only reason why I add this index, as you remember, because even though we got a 0 or 1 out of it, those don't actually apply to the target index. So we would just add, so if it's 0, we add 5 so that we know it's player 1. But if it's 1, then we add 5 and it'll be 6, which player index 2 is 6 and our defines. So when we look at that again, somewhere along the line, so player 2 is 6 here. So that's why we add the index there to offset to the correct target. So it's going to return player 1 index, or it'll return player 2 index, which is a 6. Ghost position change. So here's where we check if the change between the previous tile index and the current tile index happens. This is the save processing. So if there's been no change, then all we want to do is move the player and check collision. That's the only thing we're interested in. So here, if they're exactly the same, the current and previous one, then we know there was no change in tiles. So all we're going to do is going to check the collision with the player, and we're going to check if they're through the tunnel and they need to be wrapped, and then at the end we're actually going to move the ghost, and we're going to turn to the calling that, hey, there was no position changed. However, if it has changed and the current ghost processing means that we didn't already process a ghost yet, if we haven't processed the ghost yet, then we're going to set that we are now going to process a ghost's behavior or target, and we're going to return yes. And then since there's nothing processing here, or if the ghost processing doesn't equal 0, so it would be a 1, then return that we didn't do any processing because something else is already being processed at this time. Here is something I did. There's no check for the collision, even if it's not being processed. So there is a time when the player can actually move through the ghosts, and this is one of those times, because here I'm checking if it's already being processed. I'm not going to move. I'm not going to do any processing here at this point. If another ghost is already currently or had already been processed, so I'm not going to do anything here. And as you can see here, I'm also not checking for collisions. I could be checking for collisions here, and really I should, but I never put it in there. Something that I probably forgot or whatever. But I kind of, when I did remember it, I kind of liked it because it's still that one moment of randomness that you might actually have the ability to move through something. Is very, very rare, but it could still happen where you can move through the ghost, and kind of mimics the original arcade in some respect. Cause I kind of like that idea. But if you wanted to fix it, then here you would actually check for the ghost collision. I just wanted to make note of that. Here we're going to process the actual frightened states. So while the ghost is frightened, we're going to check if the timer is less than or equal to 0. So that means at the very beginning of this phase, we're going to, I don't even think I had to do this, but I think I did it just in case it was missed when we changed when we use that one other function where we change the state for all the ghosts. So here I reset the ghost frame. That's where that's being called. And then I'm making sure that I set it to the ghost mode correctly, and then returning. So, or, I'm sorry, no. This is when the timer has run out. Then I reset the ghost frame, and then I set it to whatever the current ghost mode is. So that's all this is doing. So this is after the timer expires. While it has not expired, we're going to see if the position changed. If it didn't, then we're just going to pop out. If it did, then we want to move the ghost towards its random target. So ghost move towards target, and we're going to give it this maximum value. So that means when we call this, as we talked about before, it will be a randomized position to move towards. So this process is the chomp state. So this is when it's eyeballs or eyes. We're going to, I think, we're just going to check if it's on the 463rd or the 464th tile index. So I'm looking for 2 tiles here, which isn't like the original, but I guess I had to do that for some reason. So that if we look at here, show, and we look at the index, so it'll be either at 463 at the top of the ghost house, or it's 464. So if it's either one of those, we're going to set the state to entering the ghost house, and then we're going to return. If it hasn't reached those tiles yet, we're going to check if the ghost position changed. If it didn't, then we're not interested in doing anything else. If none of these are true, we're going to move the ghost towards the 463rd tile. This is when the ghosts are in idle mode or scattering mode, where they go into their respective corners. As you remember, Blinky and Pinky, they randomize which corner they go to. So we're going to mimic that behavior here. So when they're in scatter mode, if they haven't changed in position, then again, we're going to bounce back out. No need to process anything if there has been no change in tile position. So, and then if the ghosts are greater than Pinky, as you remember, our order is, and again, this is something else I strategically put together, the Blinky's index 0, Pinky's index 1. Those two have the ability to, Blinky and Pinky have the ability to go towards any corner of the scatter targets that we were talking about in the dossier. So in the dossier, again, when we talk about those corners, so Here we have a tile up here, target. That's a target for Pinky. In the original game, Pinky was hard-coded here. Blinky is hard-coded. Who is this? Can't remember. It's not Sue and Pac-Man, but I think it's starts with this E. I can't remember. Claw. I forget. Anyway, so hard-coded for this one, and then Inky's hard-coded for this. But in Miss Pac-Man, they wanted to randomize all of them to any one of these four corners. However, the code, when you look at it, it may have been a mistake. It may not have been a mistake, but these two still essentially are hard-coded to these corners. The only ones that aren't and Miss Pac-Man that are actually randomized is Pinky and Blinky. Those are randomized to any one of these four corners. So, and we in our one array already have these tile indexes detailed in the array. So that's what these scatter targets are. Those four values are those four corners. So, and when it comes to anything above Pinky, so that means if it's Sue or if it's Inky, they go by their index. So again, the index is set up in order so that when we use the ghost index, it will pick the correct scatter target for that ghost in this array. So, and that's what we'll do. But if it's not those two, then we're going to get a random one out of this. So we're going to go to the scatter targets. We're going to get that range or that random number. Here's where I use that ghost offsets, because sometimes I like to offset it just a little bit for the random number generator. It seems to produce better results and what they choose throughout the game. So, and remember, we give it a 6. So, and we're looking for 4 different values. So 6, I think, is what, 64 or something like that. So we would divide 255 by 64 essentially, or whatever the random number generator could be at that point. It won't be 255 most likely, but whatever number it is divided by 64, that gives you a range from 0 to 3. So that's 4 different values, and that's what we're going to use here. So we're going to move towards the target. That target is going to be a random number for the 4 values that we have available, and that will be for Pinky, and that will also be for Blinky. Okie dokie. So this is when we're scattering, going to our corners, our random corners. This is when we're actually chasing our target. So again, we're only going to do something until, we're only going to do something when there's a change in the tile. If there's no change in the tile, we're just going to keep the ghost moving in the current direction it's in, do some collision detection, and make it that it will warp to each side of the tunnel. So that's all we're going to do when it comes to get position change. If there's no change in it, then we're not going to do any of the extra stuff that would need to be done for the ghost, so which would be define its target. So the target in the chase mode can either be player 1 or it can be player 2 in team mode. So, and this changes often throughout the game. So to mix it up a bit, to make it a little more interesting, the randomizing that gets done there for whether it's player 1 or player 2 gets changed a little bit. So we're going to figure out what our target is, and then based on whatever our ghost index is that was coming in here, whether it be whatever these 4 ghosts, it will perform or process their behavior. So like Blinky's chase behavior is to just go straight for the player. Pinky's is 4 tiles in front of the player, so on and so forth. So we'll perform those processes or those behaviors based on the current ghost that's being processed. Okie dokie, and we're getting closer to the end here. This is very long-winded. I knew it was going to be big, and I know usually having a long-form video isn't that great, but whatever. This is very much so like we did with the player. We're going to have different timings depending on if it's NTSC or if it's going to be a PAL region kind of game. But we're doing essentially the same thing as well with player 1, and that's looking at, changing the entity speed based off of whatever the stage is, and we're going to run this continuously throughout, so it gets updated every frame. There's certain behaviors in here I didn't mimic, which would be there's a behavior for Blinky. Depending on how many pellets the player has eaten, it'll actually get progressively faster and faster and faster, and they call this Cruise Elroy is the behavior. So as the player eats more players, and depending on what stage you're on, Blinky gets super duper fast and becomes faster than the player at certain points in the game. I did not apply that here. It can be. Again, I didn't do all the rules 100%. If you want to do that, that's cool. This was primarily just made for a tutorial piece. Not that I was going to go ham on this, but I probably went more ham on this than I would have thought I would have in the beginning, just because I just wanted it to have some sort of polish to it. So, okay. Here what we're going to do is I'm going to check if it's any state that's none, or any state that is a scene that isn't the game engine whenever it's going to return. There's no need for that. We're going to manually set those speeds, much like we set for the player as well. And then depending on some of the other things here, so if the entity stays frightened in the house or leaving, then we're going to have the speed essentially. So the base speed is 0, and then the fractional portion is half. So it's 255. Oh, actually, I should put 127 here. I don't know why I put 128. Probably because I don't like odd numbers too much. So I'll put it at 120, which is essentially having the speed. So when that happens, it will become slower. Again, that's not entirely true versus the original. The original actually has a table that will, depending on the stage that you're on, will set the speed for when a ghost is frightened. I did half speed, but I think in the original, there's times when they're actually faster than half the speed, and I didn't mimic that entirely here, so that may be something that you want to do too. Here, if they've been chopping their eyeballs, or they're in the process of going back to the house, we're going to double their speed here. So they're going to go super fast from when they get chomped to when they get back to the house to regown. Here, we're going to slow down when in the tunnel. So whenever they hit, so we're going to check the current tile ID for the current tile index that the ghost is on. So whatever tile index they're on, as we went over here. So here's an index. We're going to check whatever index on. So if they're over here and they're on an index here, so 354, we're going to look for that tile ID, and that's 307. If you remember, 307 was the tile that we made that if they were on top of it, they would move ultra slow. So that's what we're doing here. So the tile ID is 307, as I said. So if they're on top of that tunnel tile, then they will go super slow. Again, this is not exactly like the original. The original would only allow the ghost to be slowed down up to, I don't remember what stage it is. It might be 4, stage 5. Then after that, they don't give a crap about this. The tunnels. The tunnel should not slow them down after stage 5. At least that's what it says in dossier. They might have been changed for Miss Pac-Man. I never paid attention to it or not. But I slowed down the speed quite a bit. I'll go down to 96, which is even less than half of a pixel speed. So, and that's what I do there. And then I return. And then else, I don't even know why I return here. Probably no reason to do that. Whatever. So anyway, now we're doing much like we did with the player. We're checking each stage and then what their speed would be for each stage. So on stage 1, they are less than a pixel speed. So remember, if you had a base speed of 1, that means we at least move 1 pixel per frame. Here, we set it to 0, and now we're only moving at a sub-speed, a fractional speed of 240, which isn't quite as fast as what Miss Pac-Man is in the beginning. She's supposed to be a 1 and a 0, but of course I make it 1 and 32, as I said previously, because I'm cheating a little bit. But it will be slower than Miss Pac-Man, so that's why we set it to 240 here. And then anything less than stage 5 will get a base speed of 1 and then 16, and then everything beyond that you're going to get a base speed of 1 and then 48 as the subspeed. So they become fast, not as fast as player 1 is before it reaches, well, what stage was it? So before it reaches the 20th stage, the player goes 1 for the base speed, because it's always 1 for base speed. Any speed is always 1. But his fractional part goes up to 64. However, after that, those last, I don't know, 5 stages or so, it becomes 32, which means you're slower than the ghost, because here, after stage 5, it goes 1 and 48. So at that point, the ghosts are actually faster than the player. And then if you have like Cruise Elroy, that aspect put in there, it would even be crazier. So that's what there's. And then of course this sets the PAL coordinates that are values we would put in. Okay, so we have 2 left, much like, and this is formatted pretty much like the player source. We had the speed, and then we had the update ghost state. So this is the part where the state gets updated. So this is a little bit more simplistic here. So we're going to get the state from the current ghost, or whatever ghost we're handing in. We're going to get that state. We're going to get the current tile position. Remember, use tile offset because we want to get more of the center to the, this is because the ghosts have to go all the way into the center of the tile versus the player, where it can prematurely cut diagonally around a corner. So that's why we use this, and that was in the entity source, I believe. So we're going to get the entity tile for whatever that is. And we don't need to get the previous tile here at this point. We'll look at that later depending on the state. So then here we're also going to check a bunch of conditionals. Normally this would be to pause the ghost. There are times that you don't want to pause the ghost. So when a player chomps a ghost and then it becomes those eyes and it's moving back to the house, if you chomp another ghost, it doesn't pause the movement of the eyes. The eyes still move even if everything else is paused from chomping an additional ghost. Those will always move even after chomping another ghost. And the only time that those stop is when the player's chomped or the stage is over or something like that. So you have to take in consideration for those things. So we're just checking if the game's not playing, or if it's not paused, or we're in a state that isn't, that it's overridable. And then we return. But if it is overridable, and what I just said there in that scenario, we're going to set our ghost speed based off of this. Again, we call this every frame because we call update ghost state every frame. And then whatever the state is, we're going to call those processes that we just detailed. So ghost house, ghost leaving, entering, scattering, chasing, frightened, chomp, and points. All those, depending on whatever state the ghost is in, and can only be in one state, it'll pick this as the thing to process the behavior of the ghost. And lastly, oops, did I? Yes. The last one in here is the update ghost. Again, this is the same as the player source. This is just one call to do everything that's major here. So this will update our sprites. This will run our state, whatever it is. And then this will update for the next frame of animation for the sprites they handle. So, and that's all it does here. And that is everything within the ghost source. As you can see, it was quite big. We have, 828 lines of code here. That's a beast. So, but that's everything, and I hope you enjoyed this one. I know it was quite long. Thanks for hanging in there. I don't think it's quite, it might be as long as the last one, but we'll see you next time.